Okay, this entry task is asking the question, what is a calorie? I want you to think about it for a couple of minutes, and then we are going to explain this, and we're going to talk about it as a class. But for right now, I want you to talk to your neighbor about what you think a calorie is. We see them on food labels all of the time. Take 1 minute. Okay, 5, 4, 3, 2, 1. We're back. So what did you think about what a calorie is? Raise your hand if you have some ideas you'd like to share. Okay, now that we have your thoughts about it, let's talk about what it really is. What is a calorie? Well, write this in your composition books. Calories, it's simply a measurement of the amount of energy in a substance, calculated by measuring how much a substance can raise the temperature of water through a process of burning. So it's a measurement of energy, and specifically how much thermal energy a food source will calculate. Or you could even burn wood, or you could burn gasoline. They all have calories in them. So a calorie is just a measurement of the amount of energy in something. So here's the formula for it. Calories are calculated by multiplying the number of milliliters of water by the change in temperature in degrees Celsius. Okay, so at the bottom it shows the number of milliliters of water times the change in temperature equals calories. Please write this in your composition book. I'm going to give you 2 minutes. Five, 4, 3, 2, 1. Okay, let's look at an example. Now that we have the formula and we understand what a calorie is, and a calorie is just a simple measurement of the amount of energy in a substance. And we burn them to see how much energy they create. So let's look at an example. If we have 50 grams of peanut butter, and the 50 grams of peanut butter burned raise the temperature of 100 milliliters of water by 10 degrees. Let's look at what the formula would, or the problem would look like. Okay, so we have 100 milliliters of water times 10 degrees, because it raised that 100 milliliters by 10 degrees. So you simply multiply the number of milliliters by the change in the temperature. So it's 100 milliliters times 10. Well, 10 times 100 is 1,000. So that would be 1,000 calories. Now, calories that we think of as normally as calories that we see on food labels are really kilocalories. Those are thousands of calories. So to get an accurate amount of calories that we're used to, that unit of measurement, that kilocalorie, we have to divide by 1,000. And as you can see here, I've shown you that, where the 1,000 calories is divided by 1,000 and you end up with 1. So in this particular case, there would be 1 calorie like we normally see them in food. But the real measurement, calories, would be 1,000. Let's do another example. All right, in this example, if we burned a marshmallow under a beaker filled with 200 milliliters of water and the temperature raised from 22 degrees to 26 degrees, how many calories of energy transferred into the water? Okay, so you're going to do this problem and look at your formula, and your formula says the number of milliliters of water multiplied by the change in temperature. So you have to calculate the change of temperature and take that number, the change in temperature, and multiply it times the milliliters of water, which is 200. So do that. I'll give you a minute to do that. Five, 4, 3, 2, 1. Okay, here we go. All right, so our formula is that the milliliters of water multiplied times the change in temperature of the water, and that equals the number of calories. So let's plug in the numbers for that formula and see what happens. We have 200 milliliters of water times the 4 degrees in change in the temperature, because it went from 22 to 26. So you have to take 26 and subtract 22. That ends up being 4 degrees Celsius. So you multiply the 200 milliliters times 4 degrees change in temperature, and then that would equal 800 calories. Or we could say that it's 0.8 kilocalories, because remember, we have to divide by 1,000. We divide 800 by 1,000, we get 0.8. Let's try another example. This is going to be your exit ticket. This is the one you're going to have to turn in. So Romy used Frito chips as a fuel for warming a beaker of water. He burned 5 grams of Fritos under the beaker. The 50 milliliters of water had a starting temperature of 22 degrees and an ending temperature of 28 degrees. Calculate the amount of calories that Romy calculated for this particular investigation. You have 2 minutes. You're down to 10 seconds. 5, 4, 3, 2, 1. All right, let's look at this. Romy used Fritos as a fuel to warm the beaker of water. He burned 5 grams of Fritos under the beaker. The 50 milliliters of water had a starting temperature of 22 and an ending temperature of 28. So here's our math problem. Okay, here's our formula. As you can see at the bottom, I replaced the number of milliliters and the change in temperature with the actual numbers from our scenario. In Romy's case, he used 50 milliliters of water, so he put 50 milliliters of water at the beginning. And then the temperature of the water changed from 22 to 28. So if we take 28, subtract 22, we get 6 degrees of change. If we multiply the 50 times the 6, we end up with 300 calories. And those are little calories, little c, lowercase c, because those are actual calories. If we were converting it to regular calories that we would see on a food label, it would be 0.3 calories, because it takes 1,000 calories to make a kilocalorie. And a kilocalorie is what they have on food for nutritional facts. So there you have it. You got 300 calories or 0.3 kilocalories. And that's a wrap.